Welcome to video N3, where we're going to simplify and solve a linear Diophantine equation. Here's the problem. Let x and y be integers that satisfy 6x plus 64y equals 2. First, find all the possible integer solutions, then find the smallest possible value of the absolute value of x plus the absolute value of y. All right, so just so you know, it's the same algebra concepts as before. If I've got 6x plus 64y equals 2, I can reduce each side and really make that become 3x plus 32y equals 1. So let's just use that as our simplified problem and go from there. Okay, so step one is to check if there are solutions. So we find the greatest common divisor of 3 and 32. It's 1. 1 divides 1, so check there are solutions. Yes. Okay. Step 2. Use the Euclidean algorithm to find the greatest common divisor of 3 and 32. Remember, this is the problem we're using now. Again, I start with the larger. So 32 equals 10 times 3 plus 2. Then I take those underlines, bring them over. 3 equals 1 times 2 plus 1. That one went over there. Take the underlines. 2 equals 2 times 1 plus 0. Again, that one went over there. So once again, when you get a 0, we're going to stop. This is our greatest common divisor, as we knew. Now step 3, using the Euclidean algorithm in reverse. I'll just write that here. Step 3, use Euclidean algorithm in reverse, solve for the right-hand side. And what I usually do is I start here. Okay, so I'll just erase this so I've got some more working space. All right, so I'm going to solve for the right-hand side. So I'm going to say, I'll just kind of go like this. 1 equals 3 minus 1 times 2. And then I'll take the step above. 2 equals 32 minus 10 times 3. Then I've got the 2 here, so I'm going to substitute it into the equation above. And I'll get, in the equation above, 1 equals 3 minus 1 times 32 minus 10 times 3. Okay, and if you want to, you can put a 1 times 3 there, just if you see where I'm going with this. I'm running out of space, so I'll just bring this over to here. So now I'm just going to distribute the 1. So 1 equals 1 times 3 minus, I'll just keep it the 1 times 32, 1 times 32 plus 10 times 3. Then I've got a 1 times 3 plus a 10 times 3 makes an 11 times 3. And again, just the problem here, if we write it in a slightly different way, just so you can see it better, 1 equals 3x plus 32y. So here's the 1s, here's the 3s, here's the 32s. So 11 is going to be our x naught. And minus 1 is going to be our y naught. So again, those are my specific solutions. All right. The problem is that defined all solutions. So again, the general form, x equals x naught plus the other coefficient. So the other coefficient was 32. And y equals y naught, -1. And then again, just keep in mind these are minus the other coefficient, 3n, where n is any integer. Okay, so that answers the first part. Then the second part, let me erase all this, says I erased it. Find the smallest possible value of the absolute value of x plus the absolute value of y. So if you wanted to, you could list some other specific solutions. For example, if n equals 1, would get x to equal 11 plus 32, that's going to be 43. Y is going to be -1 minus 3, that's going to be -4. And then the absolute value of x plus the absolute value of y would be 43 plus 4, sorry about that, would be 47. You could let n equal -1 and do the same process. If n were -1, 11 minus 32, that's going to be -21. -1, that's going to be plus 3, so it's going to be 2. So the absolute value of x plus the absolute value of y equals 21 plus 2 equals 23. That's smaller. If you kept letting n be more and more negative, you can see that these absolute values are going to end up being larger and larger. Let's try this. So for n equals 0, I had x equal 11, y equal -1. The absolute value of x plus the absolute value of y would be 11 plus 1 would be 12. And that is going to be the smallest possible value. So that's the answer to part B. So there you have it, how to simplify linear Diophantine equations, solve them, and then report specific answers that are asked for.